Hello and welcome everyone. I am Avinash Sahu. Once again I am in front of you with a new video of electricity. In this video we study about the term resistance equivalent. Okay, you can say that equivalent resistance. Okay, in this video is very important for numerical purpose. Okay, so we study about one by one and its terms. Okay, so first of all our topic is equivalent resistance of a system of system of resistors. Okay, so first of all we have to understand some technical terms, which is resistor. What is resistor? Suppose you use a bulb. Okay, suppose you use a bulb, then this bulb definitely has resistance. Okay, so this device, this appliance is known as resistor. Okay, this device is known as resistor. Okay, similarly you use TV. If you use TV, then TV is a resistor. Okay, similarly you have any wire. Okay, any wire, then wire has definitely some resistance, so this is also known as resistor. So every resistor, so every electrical appliances is known which have resistance is known as resistor. Okay, so one by one we study about it. Now we have to understand equivalent resistance. If a combination of two or more resistor in a circuit, suppose that you have a bulb, okay, B1, there is another bulb B2, or says there is also another bulb B3. Okay, suppose you have three bulbs. You may have more than two or more than two bulb. Then it means this, and it is connected with a cell or a battery. Then how you represent it? You represent it like this. This has bulb 1 has resistance, which is resistance R1. Bulb 2 has resistance R2, and suppose bulb 3 has resistance R3. Okay, so equivalent resistance means it is also connected with a bulb or a battery. Equivalent resistance means in place of using 3 resistor, you use a single resistance. Okay, in place of 3 resistance you use a single resistance, which create the same performance. The performance is same as its combined. Okay, so this single resistor is known as equivalent resistance, which is equal to the performance of individual 3 resistance. Okay, you can also say that if the circuit, if in this circuit current is I and voltage is V, then use a single resistance which does not change current and potential difference. So equivalent resistance means in place of 3 resistor, what you use a single resistor. Okay, so this is known as equivalent resistance. Okay, so this is known as equivalent resistance. Equivalent, this R is known as equivalent resistance because in place of 3, if you use a single resistance, then single resistance is known as equivalent resistance, which perform the same effect. Performance is same, and it does not change the current and potential difference in the circuit. Now our topic is equivalent resistor of system of resistor. Then it means you have lots of resistor. System of resistance means a system are those in which you use 2 or more than 2 resistors. Okay, you have many resistors and so on. Suppose there is n number of resistor Okay, if you combine it, okay, the combination of what is the, it means equivalent of a system of resistor. System is a combination of two or more than two resistor. Okay, what is the meaning of system of resistor? System means you have two or more than two resistor which you combine, okay, in a single circuit. Okay, so equivalent resistance, so there we can combine, we combine resistor in two way. Number one is in series, number one is series combination, and number two is parallel combination. Okay, in series combination, all the resistance, okay, end to end, suppose this is the end point of the resistance, this is the end point of the resistance. Okay, then how you connect combine the resistor in series? The end of the one resistor is connected with the other end of the resistor. Okay, other end of the resistor, and the other end resistor is connected with the another resistor. Then this combination is known as series combination. Okay, this is known as series combination. And in parallel combination, all the ends are connected at a single point, and the other end connected with the other single point. Okay, it means all the ends of the resistors are connected between 2 points A and B. It means this end is connected at a point A and this is connected at point B. Then it means all the other resistor R1, R2 and R3 are connected with it. So this is known as parallel combination. Okay, this is known as parallel combination. One by one we study about calculate the equivalent resistance of series combination and parallel combination. So one by one we study about calculate the equivalent resistance. So I tell you what is the total resistance. Total, what is the meaning of equivalent? Equivalent means total. Okay, so what will be the total resistance in series combination? Then equivalent resistance, or you can write R or equivalent. Okay, R or equivalent. The equivalent resistance of these three are R1 plus R2 plus R3. And in case of parallel, the total resistance is reciprocal of R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. We use only 3 resistors, so 1 by R, 1 by 2, 1 by R3. If there are 2 resistors, then I use 1 by R1 plus 1 by R2. If there are 5, then how I will use 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4 plus 1 by R5. Okay, those number are here, you write that number, reciprocally add it. Okay, individual. Then after that this is known as equivalent resistance. So you need, after calculation you need to reciprocal it. Okay, so this is known as series combination, this is known as parallel combination of equivalent resistance. Okay, then question is that how these formula are derived. Okay, now derive, your topic is derive these formula. Okay, now topic is derive these formula. One by one we derive the equivalent resistance R1 plus R2 plus R3. Okay, so our first point is series combination, how we get R equivalent resistance is equal to R1 plus R2 plus R3. Okay, how we get this formula. Okay, so one by one we study about it. Okay, it means we prove R equivalent is equal to R1 plus R2. Okay, because since this is a series combination, so take series combine 3 resistor in series combination. Okay, 3 resistors. This is R1 resistor, this is R2 resistor, and this is R3 resistors. It is connected with a ammeter, okay, and this is a battery, okay, and this battery is connected with a switch, it means K, okay. Now this is the battery, so how much current is flowing in the battery, how much current is flowing in this circuit is calculated by I, okay, by calculated by this ammeter, okay. This is positive terminal, this is negative terminal. Remember this point, positive terminal is always connected with the positive terminal of the battery, and negative terminal always connected with the negative terminal of the battery. Now I want to calculate how much potential, how much what is the potential difference in this circuit, okay. If I connect it, then what is the potential difference in this? So you total potential difference is the total potential difference in the circuit is calculated by voltmeter, which is equal to the V, voltmeter. This is voltmeter. Positive terminal always connected with the positive and negative. We know that ammeter always connected in series and voltmeter always connected in parallel. So this is the circuit diagram of series combination, okay. Now you want that what amount of potential difference, okay. Tell me the direction of current. We know that the current is always from the positive terminal of the battery to the negative terminal. So suppose there is I current is flowing in this, so it calculates the I, it means it calculates the circuit current. This current is flowing in this, since there is single path, so there is current is I, and when it passes then there is again current I, because there is single path, so it has current I. It means all resistor have equivalent current I, okay. So the current in the resistor R1 is I, R2 is I, and R3 is also. It means same current is flowing in series. Remember this point, same current is flowing in series. Now question is that what are the potential across its resistor? What are the potential across its resistor? Suppose these are the 2 points, then we know that how we calculate the potential difference. The potential difference is calculated by a voltmeter. Here I use a voltmeter, and because this is first resistor, so there is a resistor, voltmeter is V1, okay. There is a voltmeter is V1, okay. Now I want to know that what are the amount in the what is the potential difference across the R2 resistor. Then I am again using a voltmeter, okay. Voltmeter is V2, okay. And to calculate the potential difference across the resistor R3, we use voltmeter R3. There is third voltmeter R3, okay. Why I am here using V1, V2, V3? Because this is in series combination, because one end of the battery, one end of the resistor is directly connected with the battery, but other end is connected with the other resistor, not directly it to the negative terminal. So it has different potential difference, okay. Similarly this and this is not connected directly with the its end, this end and this is not connected directly with the battery. One end is connected with the battery, negative term, but other end is connected with the other resistor, not to the battery. So it has different potential difference, but the circuit has total potential difference V. So circuit has total potential difference V. So the total potential difference is equal to the total potential difference of the resistor, sum of the potential difference of the resistor, okay. There are 3 devices, 3 appliances, 3 resistors, so the total potential difference is equal to the total potential difference of the circuit, okay. So in this way you get equations V is equal to V1 plus V2 plus V3. Now what is the amount of V? We know the Ohm's law is equal to V is equal to IR, okay. Ohm's law, we know that V is equal to IR. So I want to calculate the total potential difference which is in first resistor, which is V1, is how much current is flowing in the I, and what is its resistor I and R1, okay. In case of V2, what is the amount of the potential difference V2 and our resistor is R2 and current is I. Current is I and resistor is R2. Okay. Now what is the amount of potential difference of third resistor? V is equal to IR. So current is flowing is I and resistance is IR3. Okay. So this is now we also know that the total, suppose the total equivalent resistance is R. This is equivalent resistance of the circuit. Okay, suppose R is the equivalent resistance of the circuit, then what happened? We know that total equivalent resistance of the circuit, then V is equal to total resistance in the circuit is which provided by the source of the battery, V, and what amount of the current is flowing through it, I. So V is equal to I into resistance is equal to R. So put this value, this is the source of the battery, put the value of V is I. Total current in the circuit and total equivalent resistance of the circuit, which is equal to V1. V1 is equal to I R1 plus V2 is equal to I R2 plus V3 is equal to I R3. There is some common point. What are the common in this? This I is common, so take out from the bracket, and R1 plus R2 plus R3. Okay, R3. So I is cancel out, becomes R. What is R? R is the equivalent resistance. It means in place of these three resistors you can use a single resistor R. Okay, this is known as equivalent resistance. You can take R or equivalent resistance R. You can write as it or as. So R is equal to R1 plus R2 plus R3. So this is our required equation. This is a series combination. It means total resistance is calculated by simply algebraically you add these individual resistance. Okay, so equivalent resistor is the sum of the individual resistor, is the sum of individual resistance. Okay, take an example. Suppose take an example. Okay, for numerical point of view it is very important. So suppose that there are three resistors, okay, are connected in series. One is 2 ohm, 3 ohm and 4 ohm. Third one is 4 ohm. And calculate the equivalent resistor. Calculate the equivalent resistance or total resistance in the circuit. Then simply add it R1 plus R2 plus R3. It means R1 is equal to 2 ohm plus R2 is equal to 3 ohm plus R3 is equal to 4 ohm, which is ohm. Okay, so your total resistance is 2 plus 3 5, 5 plus 4 9 ohm. So equivalent resistance is 9 ohm. What it means? It means you use 3 resistor of 2 ohm, 3 ohm or 4 ohm in series, or in place of 3 resistor you can use a single resistance of 9 ohm. So it performs the same effect. So it performs the same, this equivalent resistance perform the same performance, it has the same performance as the three resistor perform in combined. Okay, so in this way you calculate the total resistance in series. Okay, so our next point is okay, our next point is in parallel combination. Okay, so to calculate, there are resistor in parallel. Okay, and it's your parallel combination. So suppose there are 3 resistor R1, R2 and R3. And we know that in parallel combination all the resistors are between 2 points. So there is a 2 points, point is B and point is A. Okay, and it is connected with a battery, okay, which has potential difference, positive terminal, negative terminal, which has potential difference V. Okay, which has potential difference V. I want to calculate what is the total current in the circuit. So we use a ammeter, okay, it has positive terminal, negative terminal. Positive terminal always connected with the positive, also same positive terminal of the voltmeter connected to the positive terminal, and it is with the negative terminal. Okay, now there is resistance R1, R2 and R3. Okay, I want to know that what is the amount of current in the flowing circuits. Okay, so current, so use ammeter A1, use ammeter A2 and use ammeter A3. Okay, because why I am using different ammeter, because when the current is flowing in this, suppose current I is flowing, then what happen, it calculate the value of I, total current in the circuit, whole circuit, calculate the total current in the circuit, and when it passes through this point, then it has three paths, so charges flow in these three paths, so there will be different currents. In this case I1, suppose in this case I2, and in this case current is flowing is I3. So now I want to know that amount of potential difference, so we use a voltmeter which is in parallel to the resistor R1, a voltmeter which is parallel to the resistor R2, a voltmeter which is parallel to the resistor R3. Why I am using the same potential difference? Because it is connected to the battery V, and this has this resistor is directly connected with the battery, because this is directly connected with the battery, the positive end, and the other end is directly connected with the negative terminal. Again this point is connected to the positive terminal of the battery, and other end is connected directly with the negative terminal of the battery. So these have the same potential difference, okay, but different current. So this is the basic point in parallel combination. In parallel combination, current is different, but voltage are same. Okay, so but we know that suppose this is current I, then this current is divided into these terminals, and when it passes from this resistor, the current is I1, through this resistor current is I2, and this resistor current is I3. Again it combine and becomes I current, okay, becomes I. Okay, so the circuit current has I, so circuit current has I, which is equal to circuit. I am talking about the circuit. So suppose that their total R is the equivalent resistance of the circuit, okay, equivalent resistance of the circuit. Then I am asking about what is the total amount of the current in the circuit. Then V is equal, we know that from Ohm's law, V is equal to, from Ohm's law, V is equal to IR. So our I becomes V by R. Okay, why I am using V? Where here V is potential difference of the battery, R is equivalent, whole circuit has the equivalent resistance R, that's why. Okay, and tell me the current in R1 resistor. Current R1 resistor is I is equal to V by R. So what is its V? Potential is V and resistance is R1. In case of this second circuit, total current is I2, because in this resistor I2 current is flowing, so I2 is equal to potential difference is equal to V, so V upon R2, and current I3 is equal to I3 current is flowing in this circuit, so I3 is equal to V by R3. Now we know that this I current, this is the total I current, and it divided into three parts. So total current in the circuit is equal to I1 plus I2 plus I3. Okay, now put the value of I1, I2 and I3 in this equation and get your answer. Okay, so our answer becomes equal to value of I is equal to V by R. R is the equivalent resistance. You can write as R eq or simply R. Equivalent resistance. Value of V1 is equal to V by R1 plus value of I2 is equal to V by R2 and value of I3 is equal to V by R3. So this is the equation. So there are some common point, which is V is equal to R is equal to, here V is common, so V is common, and 1 by R1 plus 1 by R2 plus 1 by R3. Okay, so V is cancel out and you get your required equation. 1 by R equivalent is equal to 1 by R, simply 1 by R, or 1 by R1 plus 1 by R2 plus 1 by R3. This is our required equation. So we prove this is 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is our parallel combination. Okay, remember one point. Take an example of this. Okay, take an example. Okay, it's very easy. This derivation is very easy. Okay, take an example of this case. Suppose there is a resistor of 2 ohm and there is a resistor of 3 ohm. Okay, and it is in parallel combination. Okay, then question is that calculate the total resistance in this circuit. Then total resistance, because all the ends are connected with between the 2 points. Okay, 2 points, so equivalent, this is in parallel combination. So we know that the parallel combination 1 by R is equal to 1 by 2 plus 1 by 3. Solve 8. 1 by R is equal to LCM is 6 and it becomes 3 plus 2 and it is equal to 1 by R is equal to 5 by 6, but it is not an answer because I want our equivalent resistor is R, not 1 by R. So our total equivalent resistor is equal to 6 by 5, because reciprocally then you get the value of R. This is in ohm. Okay, so this is your required equation. So you can solve further. Okay, it's equal to 1.2 ohm. Okay, 1.2 ohm. So this is our required. What it means? It means in place of these two resistors you can use a single resistor whose value is 1.2 ohm. It performs the same, its performance same as these two different resistors perform combinedly. Okay, so its value is same. You can use two resistors or 2 or 3 in parallel, or otherwise in place of these two you can use a single resistor. This single resistor is known as equivalent resistance. Okay, this is our equivalent resistance. Okay, so this is resistance in parallel combination and series combination. Okay, so in this case what you found, okay, here focus one point. Okay, this value is 1.4 and it is less than 2 ohm or 3 ohm. It means in parallel combination we get always a less, we always get a less resistance. Okay, but in case of series, okay, but in case of series, suppose this is 2 ohm and this is 3 ohm. What is its equivalent resistance? Its equivalent resistance is equal to R1 plus R2. It means 5 ohm. Okay, 5 ohm. It means this is value 2 or 3 and it is bigger than these two individuals and it is lesser than these two. It means in parallel combination we get less resistance. Okay, less resistance, and in series combination we get more resistance. Okay, so remember this point also, it's very important. Okay, so what you found in series or parallel combination, in series and parallel combination you found that in series combination, total resistance in series combination is equal to R1 plus R2 plus R3, and in case of parallel combination 1 by R1 is equal to 1 by R1 plus R2 plus R3. So this is our today's topic. Okay, thank you.